All right, so in today's video, we're going to be taking a look at time clocks. I'm going to show you how to wire up a 240 time clock. I'm going to show you how to wire a 120 time clock and a variant of a 120/240. We are also going to take a look at how to visually inspect that the motor on the back of the time clock is working, and if it's not, how to replace it. Now, it goes without saying, electricity is dangerous, so do not attempt this on your own. If you need something like this done, call a professional. But if you're interested in seeing how it's done, then stick around because that's what we're going to do. So if you could, please subscribe to the channel. And if you feel like you get anything from this video or any of my other videos, go ahead and give it a like. Now, with that said, let's go ahead and start the video. All right, so if this is a new installation, there's two questions you need to ask before you pick up a time clock. Number one, is it indoor or outdoor? And number two, is it 120 or 240? And the reason for that is because there are multiple variants of these time clocks, and each one of those is going to have a number. So a T101, a T103, a T104. And what these are going to indicate is whether it's indoor, outdoor, 120 volts or 240 volts, right? For example, this time clock here is a T103. And that basically means that it is a 240 volt outdoor box. So if it's not a new construction, then you can just look at that number that's on the box and just get the new one. What you see me doing here is how you change the time on the time clock. You pull that out and you can spin it, and that allows you to set the time, and then you use timer clips for your on-off. Now, if it's an existing box and the housing is good, then you don't need to replace the entire housing. You can replace just the guts, and there's a tab inside there. You push it up and you can pop out the guts, and then you can just replace those. That way you don't have to pull the whole thing off. What I'm showing you here now is 120 and 240 and the difference. So if you look at the white wires, you'll notice that on the 120, you have one wire on your neutral bar, and then you have the other one on line 1. And then on the other one, on the 240, you have it on line 1 and line 3. Because your time clock is line, load, line, load. So the back of the motor, that's how you're going to wire it up, basically. So this is a 240 volt, so I'm going to put 240 volts to the back of that time clock motor. Your leads for the time clock motor are going to come out onto your lines, or your direct power coming from the breaker. That way it constantly has power. So as you see here, I'm using a double pole breaker. Don't worry about the amperage. 20 amps may or may not be enough for what you're doing. This is just a double pole breaker. I'm using it for this example. So as you see, I have the leads coming out of the breaker, and it goes to 1 and 3. Again, that's because it's line, load, line, load. So your lines are your feed coming in, and your load is what is being controlled by the time clock, right? So the red wires are going to be my feed coming in. The black wires are going to be my feed going out. Now, on these time clocks, when we're dealing with pool pumps and stuff like that, we typically do not use a neutral unless it's 120. If it's 120 volts, then you have to use a neutral, and we do. But if it's 240, we don't use a neutral. It's just 240 volts going in, and then we use a ground as well. But the ground is just that, it's a ground. When it's not being used constantly. So this is how you would wire up a pump, whether it be a booster pump, whether it be a Polaris pump, whether it be your main filter pump. You would have 120 volts going to line 1, 120 volts going to line 3, and then coming out you would have 120 volts from load 2 and 120 volts from load 4. Now, in a second, I'm going to show you on the backs of this time clock. So there's basically 4 posts that are on there, as you can see here. Now, when the time clock is in the off position, those posts are pulled apart, and then when you close it, when you turn it on, they close, they make contact, and they allow electricity to flow through, as you can see here. So when I flip it on, they close and make contact, and when I flip it off, they open up. And so that's how these time clocks basically work. And then there's a motor up top that spins that little disc that's on the front, that spins that yellow disc, and you'll have timer clips that are on those yellow discs that turn it on and off. They flip the switch on and off. Now let's take a look at a 120. You'll notice right from the beginning that I have white wire on line 1, and I have the other white wire on the neutral bar. Again, you only use a neutral if it's 120 volts. You'll also notice that it's a single pole breaker. A 15 amp breaker, well, isn't enough for a motor. Again, I'm just using this as an indicator. So you see I have my power coming off of my breaker and going to line 1. And then I have my neutrals going into the neutral bus. Now on a 120 time clock, you typically don't use 3 and 4. You only use line 1 and you use load 2. Most 120 time clocks that you get from the factory, line 3 and load 4 are actually missing. They're not there. So that would basically tell you that it's 120 volts. So as you can see, I have my neutral wire coming from my neutral bus in the panel. I have my neutral wire also going to my pump, and then I have my hot wire coming from my breaker to line 1, and then I have my hot wire coming from load 2 to my pump. And that's how you would wire a 120 volt. And so there's my voltage going out. Again, on a 120, you would not use the last 2 posts, which is line 3 and load 4. Now, on the back of this time clock, you can see that the motor is 120 volts, right? So you can't hook up 240 to that, otherwise you're going to fry it and burn it out. Now, there are instances where I have seen this done, where you run 120 volts to the motor of the time clock, and then you run 240 to your pump motor. You can do this. I've seen it done. I don't like doing it. I typically don't do it. And in fact, whenever I come across this, I will usually replace that back motor, the 120 motor for the time clock. I'll usually replace that with a 240. That way everything is 120 or everything is 240. I don't like doing this 120 time clock motor, 240 pump motor. Can you do it? Yes. Is it done? Have I seen it done? Yes. I typically do not like to do it though. So as you can see, you basically wire it up the same way that you would wire a 240, except your time clock motors, wires, you wire them up 120. So as you see here, I have my time clock motors going to the neutral, and then I have my time clock wires going to the line 1. And then I have my breaker wires going to both of my lines, and then I have my 240 for my pump coming off of both of my loads. So here's power going into my line 1. Here's power going into my line 2. And then I have my power coming out from my load 2 and power coming out from my load 4. So it's line 1, line 3, load 2, load 4, and then a neutral wire going to the neutral bus. Again, can you do it? Yes. I don't like it. I think it just confuses people, especially if somebody doesn't know that much about these and they're coming in behind you. It can look very confusing to them, and it just I don't think it's a good idea. Again, can you do it? Yes. Do I see this done? I do. I don't like it. I usually switch it out. So these things, these time clocks, the guts of them, they kind of just sit in these little brackets. There's like a little shelf, and then you push it back, and there's a little tab, and it locks in. So that's how you put them in. This that I'm pointing to, there's like a little opening. There's a circular opening. What that is for is so that you can do what I'm doing here, where you take a flashlight and you point it in the back. Now, if there was power going to this time clock, you would see those gears spinning. And that will let you know that the time clock motor in the back is good, so that it is spinning. Because what happens is, if that motor goes bad, it'll either stay off constantly or it'll stay on constantly. It won't turn off and on automatically. So if the motor, like say the motor is running, or say your pump is running and that motor goes bad, then the pump won't shut off. Or if the pump is off and that motor goes bad, it won't turn on. So this is basically just a little window that allows you to visually look in there and see those gears spinning, and that lets you know that that motor in the back is working. Now, if it's not working, you can replace them. Most of the time, you just get a whole new time clock, because it's a little harder to find those motors on the back. But you can replace them, and you can find them. They're just a little harder. It's a lot easier to find the whole time clock. Now, as you see here, all I'm doing is I'm just pulling those white wires off. And then on the back of the time clock, there's 2 screws that you can loosen up. So I loosened up the other side, and now I'm loosening up this one. I'm taking this one completely out, and that will allow me to slide the motor out. And you'll see that it's a little motor with a gear on the back of it. That's all it is. So you just take that one out, you put your new one in the same way it went out. So you kind of put it back in, line up the gears, make sure it's seated right, and then you pop your screw back in. And then, of course, if it's 120 volt, then you would wire it up neutral and line 1. And if it's 240, then you would go line 1, line 3. Which I'll show you that in a second. So if it's 240, you'll go line 1, line 3. 120, you'll go neutral and line 1. And so that's it, guys. I hope you enjoyed the video. Again, like and subscribe, and I'll catch you on the next one.